All right, guys, here is the recording for the continuation of 4.2 notes, okay? Example 2, for each of the following, the interval inclusive A to B is given. Let big capital A is a point, little a, comma, f of A, and let B be the point, B, comma, f of B. Write an equation, A, for the secant line, AB, that means connecting dot A and dot B. B, write a tangent line to F in that interval A to B that is parallel to A to B. So this is really revisiting the mean value theorem, okay? So let's talk about the secant line. What do you need to write a secant line? So part A, secant line. Okay, you will need 2 points. So the first x is this one, and the second x is that one. So the first one is -1, comma, we'll find f of -1 is, let's plug it in, here we go, 1 minus -1 square equals, oh, why did I write the negative in the front? Sorry, it's 1 minus, okay. So this is going to be square root 1 minus -1 squared is 1, so this is going to give me 0. So that's my first point. My second point is going to be 1 comma, let's find that, f of 1 equals, if you see this, would you agree that it's the same thing, right? It's going to be 1 minus 1 squared, which is 0. So that's again 0. So now you have 2 points, but what else do you need? You need 2 points. You also need a slope, okay? Slope is, what's the slope? y2 minus y1 over x2 minus x1. I have 2 points, so I'm just going to use that. So 0 minus 0 all over x2 is 1. X1 is -1, so minus minus -1. But that doesn't really matter because 0 divided anything is 0. So now you have the slope is 0 and the 2 points. And here is the secant line. Y minus y1 equals n times x minus x1. You can pick either point, but I'm going to pick the positive one, okay? So y minus 0 equals slope is 0. X minus 1, but 0 anything is going to be 0. So my secant line is y equals 0. So that is the line. So that's part A. Now part B says find the tangent that's going to be parallel, okay, to that. So let's do it. I need, again, tangent line, I need 1 slope, okay? So need 1 slope. If it's parallel, the slope should be exactly the same as the secant. So slope is 0. I also need a point, okay? Well, but here's the part that's going to be kind of weird. The point, you're going to need to find where this is parallel to. So even though I have the slope of this tangent, I don't know where this is parallel to. So this is where you would need to do the f prime, okay? So f prime of x, let's do that. First, I'm going to, I should write, here, let me erase this. I'm going to rewrite the f of x equation in terms of power, so I can use the exponent rule. So f of x equals the square root of that, so I'm going to rewrite it as 1 minus x squared and then to the power of half. So now I can do f prime of x equals 1/2 times 1 minus x squared to the -1/2, then multiply by the derivative of the inner component, so that's going to be a -2x. I'm going to simplify this out a little bit, so here we go. I'm going to make this piece into a positive exponent by putting in the bottom. So on the top, I will have now -2x over 2 times square root of a 1 minus x squared, because a positive half is square root. The 2's will cancel, so now I have a -x all over square root of 1 minus x squared. Now this is the derivative, okay? The derivative, and I need the slope to be 0. So what I'm really looking for is the x location where the slope is 0. So set it equal to 0 because of this right here, right? Okay, when I take that and I set it equal to 0, so 0 equals negative x all over square root of 1 minus x squared. When I cross multiply, the denominator is going to be gone, so all I have now left is going to be 0 equals negative x, which is x equals to 0. So all I know right now, x is 0. Okay, so x is 0. Now I need the point. So what I do now is I'm going to plug in f of 0 to see where the output is, and that would be my xy point. So when x is 0, 1 minus 0 squared is going to be 0, so square root of 1 is 1. So that's my y. Okay. So now the tangent, I have the slope, okay? I have the point. I'm going to plug it in. Y minus y1 equals m times x minus x1. Parallel lines always have the same slope. Perpendicular lines have opposite and reciprocal. So my point is, let's minimize my point. Y minus 1 equals slope is 0 times x minus 0. This is going to be 0. So y equals 1 is the tangent. Okay. So what does that really mean? It didn't say graph it out, but let me give you a little graph so you can see what's going on. Okay. So here is an x and y coordinate, and this is the part you can copy or you don't have to. It's really up to you. When x is negative 1 on f, okay, so this is x and this is f of x. When x is negative 1, we found that value earlier. It's going to be 0, okay? When x is 1, it was also at 0. When x is 0, it's going to be 1. You know what this is? This is half a circle, okay? So what it's saying is that, hey, when I make the secant line from negative 1 to positive 1, that's my secant line. The secant line is that chord that you are connecting the 2 points. Is there a tangent? Okay, where would the tangent be? Okay, the tangent, remember the mean value theorem said it's going to be at least 1. Okay, one line that's parallel. So here's the line. Would you agree that this line is y equals 1? And we found it right there. What location? The location is when x equals to 0, which is back to here. We found that x right over here. See? So all of that is connected. Okay? Let's try it again. So this one, we have a radical x minus 1. And it is now from 1 to 3. So first, I'm going to see if I can find the secant line. A secant line, I need 2 points, okay? So first, point 1, so f of 1 equals square root of 1 minus 1, that's going to be 0. And another point is 3, so let's plug it in. F of 3 equals square root of 3 minus 1, that's going to be square root of 2, so that's going to be square root of 2. I have 2 points, I can definitely find the slope. Slope is y2 minus y1 all over x2 minus x1. y2 is radical 2 minus 0 over 3 minus 2 minus 1. I'm going on, my brain is kind of going ahead of me. So, all right, so this is rad 2 over 2. So this is my slope. Right? So I now can write y minus y1 equals m times x minus x1. I like to pick points that are easy to work with, so I'm going to pick this one. Okay. So that's my point. I'm going to pick y minus 0 equals slope radical 2 over 2 times x minus 1. So y equals, distribute this. That's going to be rad 2 over 2x minus rad 2 over 2. And guess what? That is my secant line. Yay! Okay. So part B said, go and find the tangent line. Okay, that's parallel to that exact line. Well, tangent line meaning that I'm going to have the same exact slope. Perfect. No need to do the work, okay? But I need to find the point, and this is the part that I don't know. So I need to do the derivative. So f of x is square root of x minus 1. I'm going to rewrite this as a power notation because I'm going to need to do the derivative. Okay, so f prime of x equals 1/2 times x minus 1 to the negative 1/2 times the derivative of the inner component, but that's going to give me 1. So I don't need to worry about that. I will set this equal to the slope because I need to find the location of x where the slope is rad 2 over 2. So the next step I'm going to do is I'm going to write the negative exponent as a positive exponent, or in this case really radical. Okay, so radical x minus 1. Set that equal to rad 2 over 2. Okay, so now I can cross multiply. So this would now be 1 times 2 is 2 equals, now that goes that way, 2 rad 2 times radical x minus 1. Okay, well, these two will cancel. So now I have 1 equals rad 2. Technically, I can put these together, okay, but you don't have to if you don't feel like it. Okay, now I remember I'm still solving for x, so I'm going to divide both sides by rad 2. So now I have 1 over rad 2 equals radical x minus 1. What we're going to do from here is we're going to square both sides. Okay, okay. So if I'm squaring both sides, I now have, what do you think you have? 1 over 2, right? The square root of 2 in the bottom becomes a 2, equal to x minus 1. Now I'm going to add 1 to both sides. So x is now 1, and another half is now 3 over 2. So my x location is 3 over 2. So to finish this point, I just have to plug in f of 3 over 2. Okay, so f was radical x, so this is now 3 over 2 minus 1. Common denominator tells me that I would need to turn the 1 into a 2 over 2, which is now a square root of 1 over 2, which is really a rad 2 over 2. So that's the point. So my y is now rad 2 over 2. I have the slope, I have a point, I can totally finish up writing the tangent equation. Are you ready? So here we go. I'm going to need more space. Y minus y1 equals m times x minus x1. So y1 is radical 2 over 2, because the tangent, you don't have 2 points, so you don't have a lot of choices for your y1 and x1, okay? The slope, oops, I need to fill in the slope, my bad. The slope is rad 2 over 2 as well, okay? X minus 3 over 2. Okay, distribute the rad 2 over 2, so y minus rad 2 over 2 equals, that's going to be rad 2 over 2x minus 3 rad 2 over 4. I'm going to move this rad 2 over 2 to here. Okay, so now I would have y equals rad 2 over 2x. I need to make this into a common denominator of 4, so now this is really 2 rad 2. So if I do that, can you see that I currently have what? Negative 3 rad 2, add 2 rad 2, the denominator 4. So would you agree that I have a negative rad 2 over 4? And that is my final equation. You know what? I would also accept this. So your book has this as an answer. If it's an ugly radical, you can leave it in point SOH form. I'm okay with that. Example 3 for 4.2 notes. For each of the following, part A, show that the function f does satisfy the hypothesis of the mean value theorem on the closed interval a to b. B, graph f together with the line through the point a all the way to b. So this is the end point. A is the beginning, and then b is the end. Find any values of c in part open interval a to b that satisfy the equation f prime of c equals f of b minus f of a all over b minus a. So that's your mean value theorem. So now this example is exactly the same as example 2 and example 1 really, but in this one they also want you to graph, okay? So more practice for the mean value theorem. That means it's really, really important. So part A. Mean value theorem says it needs to be continuous from 0 to 3. So mean value theorem, continuous, question mark, okay, from 0 to 3, okay. How you know that is that you have to understand the graph of absolute value. The domain, even though the domain of an absolute value is going to be negative infinity to infinity. So this is definitely continuous from 0 to 3. Okay. Another mean value theorem condition that we have to meet is it differentiable from 0 to 3 non-inclusive? Okay. Question mark. Well, differentiable means, is it going to have a derivative? So well, we're going to have to graph this out anyway on B. So let's do B right now, okay? B. Okay, so it wants us to do a graph from 0 to 3. When x is 0, 0 minus 1 is negative 1. Absolute value of negative 1 is 1. So now 0 up 1, okay? When x is 1, 1 minus 1 is 0. When x is 2, 2 minus 1 is 1. When x is 3, 3 minus 1 is 2. So as you can see, it's continuous, but is it differentiable from 0 to 3? The question is, no, it isn't. See the corner right there? Okay, so it's not differentiable. So part A says, show that the function f does satisfy the hypothesis of the mean value theorem, which in this case, it does not satisfy, okay? And another way that we can prove this is that we can do the limits, okay? So the limits, this is really old school, okay? You don't have to go this route, but this is really how mathematically I can show you. Limit as h approaches 0 from the left of f of a plus h minus f of a, taking you back to the formal formula, right? So as you can see, a is really, the issue really is at 1, right? So limits as h approaches 0 from the left of f of 1 plus h minus f of 1. What's f of 1? We found it earlier. F of 1 is 0. So minus of 0 all over h, which is really limits as h approaches 0 from the left. If it's the left, I would need to have it in this one. Would you agree? Okay. So that's going to be absolute value, okay, 1 plus h minus 1 all over h, okay. So limit as h approaches 0 from the left, the ones are canceling, so now it's absolute value of h, okay, over h. Remember, if it's the left, I have to take the negative, so it's going to be a negative h over h, which is going to be negative 1. So the slope, okay, left-hand slope is negative 1, which matches the graph. So I'm giving you the math concept and to back up the math, okay? I mean, to back up the graph. And limit as h approaches 0 from the right. I'm going to skip pretty much all the previous steps except down to here. So when you have an absolute value of h over h, because it's the right, you choose positive, h over h, which is 1. So as you can see, which matches up from the right. As you can see, it has a derivative, it has a left derivative, and it has a right derivative. They just don't match. So there is actually a corner. There is a corner at x equals 1, which, as you can see, again, the graph is backing us up. So what's happening is that the mean value theorem, it doesn't satisfy, okay? So fails mean value theorem hypothesis. Okay. So we got part A. We proved it up with the formal definition of the limit. We graphed it out in part B. So now part C. Part C says find any value of C in A to B okay, that satisfy this equation. So let's do the derivative, okay? So f prime of x is, all right, so let's talk about f of x. Oh, you know what, let me write the formula first, because some of you probably have forgotten what formula we're using. So the formula for the mean value theorem is f of c equals f of b minus f of a all over b minus a. So let's talk about this. Okay, we're going to do the derivative. So y equals x minus 1. But as you know, if it's an absolute value, y can be a negative x minus 1 and y can be positive x minus 1. So when you're doing the derivative, okay, so y prime is going to be, if I'm doing the derivative, this is negative 1, okay? When x is less than 1, but the restriction was from 0 to 3, so from 0 to 3. So greater than or equal to 0, but less than 1. Because the derivative still exists at the end point, okay? So the end point's right there. And over here, the derivative of that is going to be 1. And that is going to be x is greater than 1, but less than or equal to 3. Because the derivative is still true. I still have a derivative of 1 on 3. So that's why this is inclusive, and as well as that. Okay, so that's f prime. Let's do this side. Okay, so this side right here, f of b is 3 minus f of a was 0 all over 3 minus 0. And keep on going, okay, from here, as you can see, f of 3 minus 1 is 2. So that is going to be 2 minus f of 0 is 1 all over 3. And let's simplify that some more. If I were to simplify that, I now will have 1/3. So what's going on, right? So the right side, let me draw this line. Okay. So the slopes over here, it's either plus or minus 1. The slope over here is 1/3. Are they equal? No, not equal at all. So what that means is that since f prime of c is not the same as the right side, right? So f prime of c is not the same as f of b minus f of a all over b minus a. There is no such c value. C does not exist. C does not exist. Okay, so well, what does that mean? Let's go back to the graph. So here is the chord. Here's that chord. Okay, that chord from A to B. What that means is no, I don't have a tangent line that's parallel to this. Okay, I don't have a tangent line that's parallel to that. So that's what it means. C does not exist, meaning that the mean value theorem failed, and that's why we have it over here. Okay, so that's why C does not exist. All right, let's move on to B. All right, piecewise with cosine and sine. Da-da-da. Okay, part A. It wants you to tell me about the mean value theorem. Okay, so mean value theorem says it needs to be continuous. Okay, from this interval, negative pi all the way to pi. Okay, question mark. Well, the issue is really, if you think about it, the issue is really at 0, right? So let's check it out. If the output of the top part and the bottom part are equal, then that means it's continuous. Okay, so cosine of 0 equals 1. 1 plus sine of 0 equals 1 plus 0 equals 1. So checked, continuous, check. Okay. Now, is it differentiable? That's a different question, right? Differentiable from negative pi to pi. Okay. We can totally graph it out, okay, and see. Okay, so let's do that. Here we go. Let's graph it. And then if you can't really determine, then we have to back it up with the limits, okay? The formula of the limits. B says let's graph it. So let's graph it. It wants some negative pi, so I need some space. Okay. Negative pi all the way to pi. Okay. So cosine of negative pi is closed circle, and that's going to be -1. So I'm going to put a dot right down here for -1. Okay, so this is negative pi. Then cosine of pi over 2. Here's pi over 2. Cosine of pi over 2 is 0. Cosine of 0 is 1. So it goes right there. So that's my first piece. But actually, that's an open circle here. Okay? Because that does not include. So it goes like this. That's my first piece. Then let's do the second piece, okay? Cosine of 0 inclusive, that means closed. Not cosine, I'm sorry. Sine of 0 is 0, but 0 plus 1 is now 1. So it fills it up. Perfect. Fills it up. So that's why it's continuous. And we now that double check that concept right there. Sine of pi over 2 is 1. So that goes right there. I'm sorry, 1 plus 1 is 2. So this needs to go up to 2. So cosine of pi over 2 is 1, but 1 plus 1 is 2. Sine of pi is 0, but 0 plus 1 is now 1. So that will go, let's see. And I need to put a dotted 1 right here. Right there, okay? So that's sort of a little sketch. So as you can see, it's totally continuous, okay? But the issue is really at this location, right? Is that smooth? Is it differentiable? I can't really see with this sketch, so I'm gonna back it up with my formal limits. Okay, here we go. Oh, I meant to use a pen, not a highlighter to write. Okay. Okay, limit as h approaches 0 from the left of f of. The issue is really at 0. So 0 plus h minus f of 0 all over h. So if I'm coming from the left, I would have to use cosine. So here we go. Limit as h approaches 0 from the left of cosine of 0 plus h, okay, minus f of 0. F of 0 must come from here. So that means f of 0. Sine of 0 is 0. 0 plus 1 is 1. So that's 1 all over h. Okay. So next, well, 0 plus h is 0. So limits as h approaches 0 from the left, cosine of 0 minus, I'm saying cosine of h, because 0 plus is h, minus 1 all over h. Now this is a tricky piece, okay? What I'm going to do now is I'm going to manipulate, okay? I'm going to multiply the top and bottom by the conjugate, because right now I can't use substitution, okay? Because the h is still in the bottom, so I can't put in 0 for the bottom because that's not going to help me. So I'm going to multiply top and bottom by the conjugate to see if that will help me. So with that, I'm now going to get limits as h approaches 0 from the left. On the top, that's cosine square of h, still minus 1 all over. On the bottom, I have h times cosine of h plus 1. Okay, so that's my bottom. Okay, then from here, with more manipulation, I will now limit of h approaches 0 from the left. Okay, so here's the part that I'm going to change, and I hope you remember. Let's highlight this piece, okay, and write that in the bottom. Sine square of h. So sine square of x plus cosine square of x always equals to 1, okay? Well, I have cosine square, so what I'm going to do is I'm going to move the sine square over, which we all know, 1 minus sine square, it's always going to be cosine square of x, okay? But I have cosine square minus 1, so what I'm going to do is I'll move the 1 back, okay? So that means cosine square of x minus 1 is really negative sine square of x. So that's what I'm going to do. I'm going to substitute this with negative sine square of h all over h times cosine of h plus 1. Then from here, I would now manipulate some more. I'm going to break that sine square into 2 pieces, okay? So h approaches 0. I'm going to do negative sine of h times sine of h. Okay, all over. This bottom, I can break that into two pieces because it's multiplication. So that's cosine of h plus 1, and then times sine of h. Okay. Well, if you remember correctly, the limit as h opposed to 0 of sine of h over h is actually 1. Okay, so let's go back. So limit, as now I just have this last piece to work with, so negative sine of h over cosine of h plus 1 times, okay, so the limit of that's 1. Then from here, what we can do now is I can actually substitute in 0, okay? So that's going to be limit as h approaches 0 from the left, sine of 0, negative sine of 0, over cosine of 0 plus 1. Well, sine of 0 is 0. Cosine of 0 is 2. So 0 over 2 is 0. So the left-hand derivative is 0. Then let's do the same thing for the right-hand derivative. But the right-hand derivative, we can do this a lot faster because we can skip a lot of steps, okay? I'm really just going to go straight down to, let me just fill in the information really quickly. Let's see. Everything, it's pretty much exactly correct. So, okay, so let's fill this in. So f, again, the issue is really at 0 plus h minus f of 0 all over h, right? Because this is a right-hand derivative, I'm going to be using sine, okay? So limit as h approaches 0 from the right, I'm going to plug in, here we go, 1 plus sine of 0 plus h. And earlier, f of 0 is always 1, so that's all that is right there. So these two are now going to cancel. So limit as h approaches 0 from the right, 0 plus h is h, okay? So sine of h over h, which we know is 1. All right, so as you can see, they don't really match up. They have derivatives, but then that means there is a corner. There is a corner at x equals to 0. So is it differentiable? The answer is no, okay? Not differentiable from negative pi to pi. Okay, so that is the long way of proving whether it's differentiable or not. So we graphed it out already. Okay, so let's see. Part B says, graph f together with the line through the point. Okay, so let's do a line. I'm going to need some sort of a ruler. So here's the line. Okay, so there's that line, that secant line connecting those two. Okay. Part C, I forgot. I did B. B took so long that I forgot. The proof for A took so long that I forgot. Find any value of C in between the interval A to B that satisfy the function. Okay, let's see it. From just looking at this graph, would you agree there might be how many? 1, 2, and 3, okay? So let's see if our math matches with our picture. So part C says find all the C values. Okay, so let's look at the graph again. Your piece Y has two pieces. So the first piece is really Y equals cosine of x. And the second piece is really Y equals 1 plus sine of x, okay? I'm just going to take the derivative separately and then put it together. I hope that's okay with you. Y prime equals negative sine of x for that piece. Y prime equals, the derivative 1 is 0, and the derivative of sine is going to be cosine of x. So now I can just put them together. So Y prime is piecewise, okay? Negative sine of x, and x is from negative pi all the way to 0. And again, this one, it's inclusive because the left-hand derivative does exist at that point. And now I'm going to write cosine of x, and this is going to be from 0 all the way to including pi, okay? So that's my derivative. Let's find f of b minus f of a all over b minus a, because later I have to set them equal to each other. Okay. So let's do it. F of b is pi, minus negative pi, all over b again is pi minus a negative pi. So let's fill it in. Cosine of, I need to do pi first, okay? So pi is, which function am I using? Let's see, I have pi, so it's going to be 1 plus sine of pi, okay? So I can't use cosine. Okay, that'd be 1 plus sine of pi minus negative pi is now going to be cosine. So that's going to be minus cosine of a negative pi all over, that's going to be 2 pi. So sine of pi is really 0, so 1 plus 0 is still 1. Cosine of negative pi is negative 1, so that's what I now have. So that's going to give me a 2 over 2 pi, which is really 1 over pi. Okay, so that's the slope of the secant line. What do I do with that? Okay, so this is really where it is tricky. On the left side of the graph, okay, so because you have two pieces, so that's why it's a little tricky. When we have this right here, okay, let's just focus on that. Let's find c for that. So negative sine of x, let's replace x with c. Not really important by any shape or form, okay, so now it's really negative sine of c. I need to, would you agree, I need to set that equal to 1 over pi, okay? Because that's, remember, these two have to be equal, okay? Whee, that right there. So I just need to solve for c. So that means sine of c equals negative 1 over pi, okay? So slowly, sine is negative in these two quadrants, okay? Because your restriction was from negative pi to 0. So I have to cover both of the quadrants, okay? Quadrant 3 and quadrant 4. When I put this in the calculator, c equals sine inverse of a negative 1 over pi. The calculator is going to give me a decimal, a negative 0.324. So that's this first angle right here, negative 0.324, okay? I need to get this angle. Well, that angle is that piece right there less, okay? So how do you get that second piece? I'm going to subtract, okay? It's still going to be a negative angle, so I want you to keep that in mind. So it's really tricky. I need you to really think about this. This whole angle is really negative pi less that piece, okay? So negative pi is less that piece, so I'm going to subtract, okay? But I want you to understand this. But I'm going to subtract that piece, okay? So 0.324. But two negatives will make it a positive. So negative pi plus 0.324. When I punch that in the calculator, I should have a little bit less than 3.14. So it's going to be a negative 2.82. So those are the two spots, okay? All right, so that's your piece right there. So make sure we understand why that is, okay? Now, let's go back and look, okay? Negative side, would you agree that there should be two c values? Perfect, we found two. On the right side, notice how there's one c value. Hopefully we can find one of them, okay? So right side, now I'm going to pick that piece. So I'm going to say cosine of x equals to this same thing right here, which is 1 over pi. You can keep x as x, but you can substitute x as c. It's really not important, okay? So here's where I'm at. And I'm going to, again, take inverse, so c equals cosine inverse of 1 over pi. My calculator is going to give me, remember cosine is positive in this quadrant and that quadrant. Right away, my calculator is going to give me a answer 1.25, which is this piece, okay? Now, the positive restriction is from 0 to pi, okay? So as you can see, quadrant 4 is not in my restriction, so I don't need that piece. So I can just stop right there, which matches up with the graph that we had, right? The graph that we had said, said, hey, there should be one C value on the right. So now we have a total of 3 C values. So C are from negative 2.82, and then we have a negative 0.324, and we also have a positive 1.25. So when it comes down to it, those are all of the C locations.